students. Yes, it's me again, Madam Gracious Kanzini from Educare Tanzania. Welcome my Form 3 students. We are proceeding with our chemistry session series, whereby we are proceeding with our amazing topic known as ionic theory and electrolysis. My students, in this topic we have several of subtopics where we have the concept of ionic theory, we have the concept of electrolysis, we have the concept of laws of electrolysis, and finally we are going to sum up our topic by considering the application of electrolysis, how this electrolysis is applicable in our daily life. But it's so amazing that we have already covered the first subtopic, which is all about the concept of ionic theory. And also it's so amazing that we have started in our previous session the concept of electrolysis, whereby we have learned about the electrolysis mechanism, how the electrolysis takes place, the electrolytic cell, the factors for the preparation of the discharge of the ion. But my students, today we are proceeding with the electrolysis of selected electrolytes, kwamba kuna some of electrolytes zimekuwa selected, so as we have to study them. Now welcome to start our session, kwamba the following is the selected electrolytes we are going to study. We are going to study on the electrolysis of dilute sodium chloride solution with the carbon electrode. We are going to study on the electrolysis of sodium hydroxide solution with the carbon electrode. Also, we are going to study the electrolysis of copper 2 sulfate solution with the carbon electrode. But also we are going to study the electrolysis of copper 2 sulfate solution with the copper electrode. As well as we have the electrolysis of dilute sulfuric acid with a carbon electrode. Finally, we are going to have the electrolysis of molten potassium iodide with the carbon electrode. And my student, in this selected kind of electrolysis or electrolyte to be studied, all of them are made with the carbon electrode, mean that those graphite electrodes, but only with the copper electrode is different, but all of them they involve the graphite electrode or the carbon electrode. Now, my students, through studying this selected electrolysis of this electrolyte is where we are going to see how those factors of nature of electrode are applicable here, the nature of electrochemical series applicable here, where the concept of discharge of the ions applicable here, the concept of ionic migration, the way the electron tend to move during electrolysis is applicable here, the dissociation also is applicable here. Now, let us start with the electrolysis of sodium chloride solution with the carbon electrode. Now, my student, this is the electrolytic cell, which is the apparatus used to support the electrolysis process. And here, our electrolysis is made up of sodium, dilute sodium chloride, means that our molten state or our solution which allow the current to pass through it is made up of sodium chloride. Now, this is the graphite electrodes ambayo tutakuwa na cathode electrode and the anode electrodes, but also this is our outer or external power energy, which is battery and tend to supply the direct electric current, and this is the molten state dilute sodium chloride solution, and this is the partitions. Now, my student, let us see the components involved here. The components involved here in the electrolysis of sodium chloride, we have the sodium chloride itself and the water. Now, how this dissociate? We have the compound of sodium chloride as well as we have the compound of water. But the sodium at the cation now, the dissociation, the ion present as follow, kwamba at the cation we are going to have the positive charge ion, whereby we are going to have the positive charge of ion of the sodium chloride as well as from dissociation of water. Kwa hiyo kutoka kwenye sodium chloride tunaenda kupata potassium positive charge ion, sodium positive charged ion, vile vile tunaenda kupata the hydrogen positive charged ion. Lakini katika an ion we are going to have the chlorine, we're going to have the chlorine which is negative charged ion, but also we are going to have the OH which is negative charged ion. Another concept is all about migration, how these electrons or these ions tend to move from one place to another, how tend to move toward the electrode or from the electrode. Now we have the cathode, whereby the sodium and the hydrogen will move toward the cathode, and the chlorine and the OH negative, they are moving to the anode. But here we are going to consider the preference of discharge of the this ion, is where we are going to see the concept of discharge. Now the concept of discharge from the electrochemical series, hydrogen cation will discharge at the cathode and the hydroxyl anion will discharge at the anode, whereby at the cathode here we are going to have the discharge of hydrogen gas, hydrogen aqueous, and we are going to form the hydrogen gas. But also in the anode, at the anode we will have the discharge of hydroxyl ion, whereby we are going to have the water molecule and the oxygen gas, as well as these electrons are gained because this is negative charge ion, there is gain of electron. But our overall reaction means that the number of electrons gained or lost in the reactant and the product should be balanced so as to cancel each other. Now our overall reaction, it involves the sum of the first reaction in the anode and the second reaction at the cathode, whereby we are going to have the 4 molecule of hydrogen ion positive charge and 4 molecules of hydroxyl ions which is negative charge, and our end product or final product we are going to have the water molecule, oxygen gas, water molecule, hydrogen gas, as well as oxygen gas. Now what are the products? Hydrogen gas will be produced at the cathode, and the oxygen gas will be produced at the anode. Haya, hii ndo product ambayo itatokea kwamba hydrogen itazalishwa at the cathode, lakini oxygen it will be produced at the anode. Kama tulivyoona kwenye ile overall reaction, tumempata water molecule, hydrogen gas as well as oxygen gas. Kwa hiyo oxygen anakuwa at the anode, lakini hydrogen anakuwa produced at the cathode. Something to note here is, as the process continues, element of water will decrease and final sodium chloride become concentrated, and the result discharge chloride and ion to produce the chlorine gas. Kwamba kadri process inavyoendelea, this concentration of water tend to decrease while the sodium chloride concentrated in the solution. If it is concentrated now, the mean that the OH will be stopped to be produced, while what will be discharged is sodium, is chlorine ions at the anode. So what will be the reaction or the product at the anode is production of chlorine gas. As you can see here, the anode, chlorine, the electrons, it tends to be discharged into chlorine gas. Now my student, let us see the electrolysis of sodium hydroxide solution with carbon electrode. In this electrolysis, it does not differ much with that of sodium chloride. What differ here is that the solution, the molten solution of this compound is made up of sodium hydroxide, whereby that one was made up of sodium chloride. So just a solution change, lakini everything is the same mechanism, each and everything, the diagram, this thing, electrolytic cell, what is happening. What just change is this dilute sodium hydroxide solution. Hii molten state ndo peke yake inabadilika. Now what are the components from this sodium hydroxide? First we have the sodium hydroxide, and secondly we have water as usual. Now let us consider the dissociation. The ion will be dissociate, whereby at the cation, in the compound of sodium hydroxide, we are going to have the sodium, and in the water we are going to have the hydrogen. But an ion, the compound of sodium chloride, we are going to have the chlorine. But also, no, I mean in sodium hydroxide we are going to have OH, as well as from water we're going to have OH. So that's why you see OH at the anode. So the part of discharge is the same with that of sodium chloride electrolyte. Now here, from electrochemical series, hydrogen cation will discharge at the cathode, and the hydroxyl ion will discharge at the anode. Kwamba at the cathode ndo hydrogen itakapokuwa discharge, kwa sababu tuna hydrogen na sodium. Lakini tunajua katika kwenye electrochemical series, as you go down the electrochemical series, is where the ease of discharging of ion tend to be preferred. So the hydrogen will be preferred to be discharged compared to the sodium, kwa sababu sodium itakuwa ina exist at the strong. Now when you come at the anode, where we talk about OH, it will be discharged into water molecule and the oxygen gas. Overall reaction is like this. 4H plus 4OH neg, we're going to have the hydrogen gas, water molecule, and the oxygen gas. Now what are the products? Hydrogen gas will produce at cathode, oxygen gas will be produced at the anode, where water remain in the solution. Kwamba hapa the hydrogen inakuwa produced yes at the cathode, lakini oxygen inakuwa produced at the anode, lakini at the same time water yenyewe inaendelea ku remain in the solution, maji yanaendelea ku remain katika solution. Now what are the observation? Kwamba bubbles at the electrode due to the formation of gases, kwa sababu kuna hizi formation of gases, for instance hydrogen gas, oxygen gas, so there will be a bubble formation. Bubble formation will be observed during the electrolysis mechanism. Another selected electrolysis is another selected electrolyte is electrolysis of copper 2 sulfate solution with carbon, graphite, or electrode. Consider the diagram. This is the diagram of copper, which show that this is the copper sulfate solution, this is copper cathode, copper anode. So from the factor which was the nature of electrode, here is where you can see our electrode here is made up of copper and our solution is made up of copper. So what is going to happen in the dissociation, in the ion, dissociation of those ions in the discharge? Now let us see kwamba component ni copper sulfate and water, and the dissociation ions, it will be as follows. The compound is copper sulfate and the water. Now at the cation we are going to have the copper as well as hydrogen, but also an ion we are going to have the sulfate as well as the hydroxyl. At the cathode we are going to have the copper ions as well as the hydrogen ions, but also we are going to have sulfate with the OH. Now let us see the discharge of this electrolysis of copper 2 sulfate. From electrochemical series, copper cation will discharge at the cathode, while the hydroxyl and ion charge will discharge at the anode. And this is the reaction will be observed kwamba copper inakuwa discharged at the cathode kupata copper metal, mean that it tends to lose their electron. But also at the anode, hydroxyl gain electron, and where we're going to have the water molecule and the oxygen gas and those electrons. So yenyewe inakuwa discharged at the anode. And finally we are going to have our final overall equation of our half reactions at the cathode and the anode, whereby we're going to have the copper 2 copper ions plus hydroxyl ions, we're going to have copper metal from solution to metal. And also we are going to have the water molecule and the oxygen gas. Now let us see the product. Copper metal will deposit at the cathode, oxygen gas will produce at the anode, and the water remain in the solution. Kwamba as you can see this diagram, kwamba copper metal anakuwa deposited, anakuwa deposited at the cathode. This is the cathode electrode. Here behind unaona kuna coating imefanyika, so this copper imekuwa zimekuwa deposited here in this electrode. Lakini the oxygen gas will be produced at the anode and water remain in the solution. Kwamba this is oxygen gas, bubbles zinakuwa zinatokea, lakini water ina remain in the solution. Now let us see the observation. Solution turns blue copper due to the color of the hydrated copper 2 sulfate. Kwamba hii yenyewe copper 2 sulfate kwa sababu the electrode is made up of copper. At the same time the solution is made up of copper. Now the solution turn blue color due to its color of hydrated copper sulfate. Kwamba yenyewe ni ya blue. Kwa hiyo solution itabadilika rangi na kuwa blue color of the copper 2 sulfate. Another is mass of cathode increase due to the deposition of copper metal. Mass inaongezeka. Kama ulivyoona kwenye mchoro hapo kuna deposition, this mass of this copper inakuwa deposited to the cathode. I mean the cathode electrode. So the mass of the cathode increase due to the deposition of copper metal. Another is mass of anode remain constant. Kwamba mass of anode yenyewe ina remain constant kwa sababu at the anode tumeona kwamba kinachoonekana ni zile bubbles, gas inakuwa involved there, then those bubbles are observed. Another is bubbles at noble due to the formation of the oxygen gas. Yes, so tumeona kwamba yenyewe no mass increase kwa sababu kule hatuna deposition, lakini vile vile kunakuwa na hizi bubble wakati hii gas inakuwa formed. Now my student, after looking this concept of some of selected kind of electrolysis of selected electrolytes, now there is task for you here. Try to attempt so as you can increase understanding concerning this concept. The question is, describe the electrolysis of copper 2 sulfate solution with carbon electrode. I hope my student will attempt the task because you have already passed through the session, you have understood. Also, I know my Form 3 student, you will go through the books and you will go through checking the library books, checking the past papers,